Elisha Caudill, teacher at the Academy for the Arts, Science, and Technology. Today I plan to share with you the lesson titled Everyday Algorithms, How Data Influences Your Feed for the Coastal Carolina University Computer Science Lesson Competition. The topic of algorithms is extremely popular in today's time. The lesson intends to capture the students' attention by connecting to something that they use daily, which by and large is social media algorithms. When students realize they are recreating their own For You page, or what we know as a ranking algorithm, we hope that their engagement increases. They shift from users that are passive to a creator, to understanding how decisions are made based on data, and then also are able to review and observe how small rule changes to that algorithm impact the outcomes. It will allow them to have meaningful discussions while being reflective on how computer science invades the relevance within their real world daily. So the lesson intends to estimated take time for about an hour. The audience will be pre-service teachers with little to no computer science background. The student learning objectives are understanding algorithms as a step-by-step decision-making process, explore how data influences algorithmic outcomes, identify bias in algorithmic systems, and simulate a ranking algorithm using formulas in Google Sheets. The teachable content is linked here and will take the student through the concept of everyday algorithms and how that data influences what we see in social media. The student learning objectives are again restated. Additionally, there has been key vocabulary that has been included to help the student understand the important components and words that would be needed to help them in the activity. Embedded within the teacher content is a hook that could be used in class. The teacher could present this information on the board to ask the students to do some brainstorming or prior knowledge reconnection. In an online setting, the student could still do the brainstorming, but maybe the activity is pulled out of the teacher content and posed more of a discussion post strategy. The image on the right-hand side are some simulated TikTok feeds, and it's asking the students to review those images and make a prediction about what kind of person would see these images in their feed. So a lot of assumptions can be made about the type of person that would search for Trader Joe must-haves for busy moms. Some reset routines and some Target home decor maybe could mean that this is a mother who's looking for some easy dinner ideas while remaining somewhat healthy. The person on the right could be a traveler who's being conscientious about what they're eating prior to going on vacation. The teacher content then goes into detail about having the students think about the last time they opened one of those social media apps and thinking about why did the videos appear. It introduces the concept of algorithms and describes it as a step-by-step set of instructions used to make decisions or to solve problems. It talks about how social media uses algorithms to decide what content to show you, and that those decisions are made upon the data. Data is then introduced as information collected about the user. Social media often tracks what we like, what we watch, including videos that we watch all the way through, what we skip, and what we search. The data is then used to predict what you might want to see next. Algorithms are then tied back to the data by looking for patterns. So if this user likes food videos and they watch them all the way through, and they search for new recipes, the algorithm analyzes that and decides, well, I think this user may want to see more food content. And then in return, we have a recommendation system or a ranking algorithm. The idea of quantitative and qualitative data is introduced, and it's important to know the distinction and difference to determine how that ranking algorithm will use the data, whether that's specific numbers that are used in calculation or words or categories or descriptions that are used in searching. The idea of algorithmic bias is introduced in how a system or an algorithm can produce unfair or skewed results based on data that may be missing, biased, or some human decision or influence on how that algorithm is built. The student will explore in an activity the human decisions on how decision making can be impacted within algorithms. The lesson then caps off with a video reinforcement of how algorithms are helping shape social media. Post-teachable content, there have been some DOK questions that the students can discuss. If this is an asynchronous model, they can be posted for students in a discussion forum, which could spark some conversation if they are asked to respond to each other. In class, they could be facilitated through a round robin model where each student would share out their thoughts and feelings and have to summarize and share out. At which point, a transition to the activity called Becoming the Algorithm would be necessary, in which the student will now have the opportunity to become the human building a recommendation algorithm. They will make a copy of the algorithm activity spreadsheet for use in their Google Drive. They'll notice that there's categories like watch time, a watch time value, which is empty, and score, which is empty, and then also a label for some video recommendations, which will come from the step-by-step directions. Then they also have a section for bias data, which will be used and explained through the step-by-step direction. In the activity sheet, there's also the step-by-step guide that I previously referenced. And it reintroduces the idea of this algorithm that they looked at the very beginning of class. They now have some schema and understanding of how that information gets into that person's feed. Now they're going to take the role of actually making a recommendation system. So they'll review the data that was provided in the spreadsheet and decide what needs to be converted to quantitative data. If they're unsure of the quantitative data, they could refer back to the teachable content, but in which case we're looking for them to take that watch time column and apply numbers in that next column. So for example, if watch time is high, maybe that gets a rating of 3, proceeding by medium with a 2 and 1 for low. They'll then create a formula that would combine the likes and the watch time to get an overall score. They'll then sort the data from highest to lowest by category and score. The top categories become the recommended content for this recommendation algorithm. They're then tasked with generating a feed. So instead of guessing what the user wants to see, we're going to use the ranking algorithm that was designed and will be shown up in the score category. The top 2 categories will be selected. Student will have the autonomy to choose 5 videos from YouTube or another video sharing platform based on score weighting for the user to watch. An example would be if food has a score of 8, then they'll receive 3 videos about food, and pets with a score 7 would get 2 videos. You'll notice that fitness and travel don't make the cut, and so they're not going to have any videos in their ranking algorithm that represents that. They'll then inject bias, where they're using some human influence to change the data. This time, we want to build a formula that modifies that original ranking calculation, which would give a higher weight to likes. In this one, you'll notice that while the watch time for the food category is low, it does have a high amount of likes, which is where we would want to see the transition into the changing of the categories based on data collection. Again, they'll sort the new data and then regenerate the feed, reorganizing those videos based on the data that has been changed as a result of the injection of bias. The rubric for the activity is included. The domains are analyzing that student or user data. Did they effectively go through and change any qualitative or quantitative data? Did they develop a logical formula that effectively combined the recommendation rules? Did they generate the video recommendations based on score weighting? And did they test how changes affected those outcomes by recalculating the scores? And you can see that there's a breakdown of 4, 3, 2, 1, so the teacher can effectively score. At which point we'll transition to the reflection, where students would be given the opportunity to review and reflect upon how they served as this algorithm. They'll go through a series of 5 different questions where they can reference their work as possible or real world activities, but allows them to put the thinking of what they just completed with the simulation of the ranking algorithm into process. And then there's also a rubric for student reflection. That way this teacher can go through and score without injecting his or her own bias. All of the documents are here linked. All in all, I estimate that the duration of this would take an hour, maybe possibly more, depending on how in-depth the discussion questions were and how long the activity itself took. Should you have any questions about this activity,